tutorial starts with a song, but it's only a few seconds long. Let's get started with animation. Hello folks, I hope you're fine. This is the last tutorial before the summer break, and I want to point you to a sort of bug, and a very nice bug report, and a solution to this. This is a node system in the Bifrost Graph editor. If you want to access it, you need to go in Maya to Windows and Bifrost Graph editor. That's where we find this. We need to set up all these nodes here, and you'll be surprised how powerful this can be. This, for example, is one of the outputs of this node system. Pretty excellent. It was much more faulty before I found or got notification of how to fix it, but I'll show you this later on, because now we see there's a whole mess here, and we don't want to have that mess that comes from working around with the nodes, dragging them, making new connections, etc. So if you press somewhere in the empty space here and press the key L for layout, you get a very clean layout of the whole thing. So it runs from a p-torus shape and the combustion settings to the output node, which has an output of an Aero volume. That's what you just saw. I show you basically how this works, and there are other tutorials. Actually, I did quite a few about Bifrost Graph, and you find how to set up these things. So let's just follow the flow of the system here. The polygon torus, I hide it here in the outline. It's hidden. You normally drag and drop it with the middle mouse button in this field here. So you start with the geometry, because the geometry will be the emitter of air. For air, you need three nodes. One is the source air, the simulate air, and the third one is the Aero solver settings, because you need solver settings in order to make this adjustable. Now, the torus feeds its mesh, meaning its geometry, into the geometry input of the source air. The air source feeds its air source output into the sources of the simulate Aero. The simulate Aero sends the Aero volume to the geometry of the assign material node. That's the bridge between the graph, the Bifrost Graph system, and the Arnold system. Assign a material. That's basically something we usually do with the right mouse button on any kind of geometry, but here we need an abstract node which is called assign material. Now, what kind of material? Well, an AI standard volume shader, and that volume shader it needs to be not just a surface shader, but a volume shader, because we deal with volume. We have combustion, we have lots of things happening inside and outside, so we need a volume shader. And the shader output goes into the volume material input of the assign material node. And the outer geometry output here goes into the output, the final output. That's actually what we see. That's what we render, the Aero volume here. Now, something we missed is this. The Aero solver settings have solver settings output, which go into the settings of the simulate Aero. And the combustion settings, we don't necessarily need them, but they're quite handy. They send their output, the combustion settings. They don't have an input here, at least not in my node system here, to the combustion settings. So that's pretty forward. If we had a collider, we would add a collider here, and it would collide with this part here in the simulation of the Aero. Just to recap this, because it looks more complicated than it actually is, the torus goes into the source air into the simulate Aero. The simulate Aero is the connection, the node which collects the combustion settings and the Aero solver settings right here. So this is finished then. And then it feeds its output, the volume output, not the points in this case, the volume, into the geometry input of the assign material node, which gets a standard AI volume shader from this node here, which feeds into the volume material, and then the whole thing goes out into the output. Let's minimize this for a second. One of the drawbacks here is that the simulation is so heavy that it takes time to actually simulate, and as far as I know, you cannot directly cache it. like you could cache encloth, for example. So let's run the simulation, and you see how slowly it runs. And you don't see anything here. That's interesting too. I have a perspective camera number 1 actually. And when I stop it here and I render the scene, I can actually render it here in the viewport, Arnold, and use this button. It takes a while to collect all the information, and then we'll see a rendering. So the viewport does not tell us everything. We can keep on simulating here, frame 29, etc., and keep the Arnold sort of real-time renderer active, and now we see how this thing evolves. I'm accelerating this just a little bit because I want to go to sort of frame 100. And I cannot just jump to 100 because it needs all the run-up to frame 100. And you already see that this does not have to do very much with an air simulation. It looks more like styrofoam or something like that, with, as we can see in just a few seconds, a lot of faults. I used this file in a previous tutorial to demonstrate the problems with the Bifrost Graph system, because it's not very well documented, and plug and play does not really provide an excellent result here, as we can see now. So this is really messy, and since I did this in a previous tutorial, I demonstrated this problem here without a solution, I got an email from Autodesk, from the development unit of Bifrost Graph. This is the email I got from Tim Wong from the Autodesk Bifrost team. He wrote, "Hi Max, my name is Tim Wong and I'm from Autodesk working on the Bifrost team. I'm contacting you about the Aero simulation problem that you show at the beginning of your video so and so. Would you be willing to send over your scene file demonstrating the voxel artifact? We'd like to take a look at the scene and improve on the results. As a brief description of the type effect you were trying to achieve would be helpful." Example screenshot right here from my tutorial. I sent him the scene file of the rendering, which you just saw, and he wrote back, "Hi Maximilian, looks like there is an issue with how the AI standard volume was set up in your scene. If you choose the shader and click the preset option near the top, there is a default Bifrost Aero preset available." Actually, I did not know that. Choose replace and then it should fix your scene. Basically, and that's important now, the default channels on the AI standard volume shader are incorrect for Bifrost Aero. That means incompatible with Bifrost Aero. For example, the default density channel points to temperature, which is non-existent channel in Bifrost. What you want is voxel fog density, etc. I'll show you this in a second. Finally, Tim wrote, "I'm glad it worked," because it did work. "We investigated a bit more and here's a more robust explanation. The AI standard volume material is using a channel as emission that does not exist, which causes Arnold to just render the tiles." Now let's have a look. What I need is the attribute editor of the material, the aiVolume. One way to go there is right mouse click here on the object and material attributes. And here I find a Lambert shader, which is not exactly what we need because we have a special shader set for this volume here. Now let's go to the hypershade, which is this icon. And in the hypershade window, we find AI standard volume. That's exactly what we need. We can minimize this again, and now in the attribute editor, we have the AI standard volume. And in the AI standard volume, you see the density channel is set to temperature. Further down here, we see that the emission is set to heat and the temperature is set to temperature, but we need another string here in order to make this work properly. Now what I'll do is just as I was suggested to do. So I want to show you the presets here. That's why I extended the attribute editor a bit. So we click here and we have the default Bifrost Aero. That's what Tim was relating to. And we have foam and smoke as well, which are interesting as well. So when you deal with smoke or foam or snow, for example, you can choose one of these volume materials here. But in our case, we have an Aero solver, so default Bifrost Aero, and we replace this. You will see immediately when we replace this that the parameters here will change. The color will go away because we'll have a standard gray, and the heat input here in the emission will change as well. So let's do this. And now we have a white here, and we have emission is the voxel temperature, which is good because the emission goes with the temperature. Here we have the temperature which goes with the voxel temperature, obviously, because we have a temperature node in our, or parameter in our scene. And as you can see in the Arnold rendering, we have a totally different geometry, which reminds us much more of an Aero system than of what we've seen before. So this is quite drastic. Let us go to the presets again and go to foam and replace this by foam, which is faulty again because we don't need certain connections. It looks similar to what we had before. It's just not appropriate for this. And smoke is a little bit better, but as you can see, the AI standard volume shader with the default Bifrost Aero is just ideal. So I show you the two entries basically side by side, and keep in mind when you use an Aero system, use the standard volume preset for the default Bifrost Aero system. Support is very, very crucial. And you find support in the Maya forums, well, I think they're called Autodesk area. Excellent support. And I cannot give you that support because I just don't have the time for it. And in this case, it worked a little bit differently because Tim saw the video, the tutorial I posted in the past, and he wanted to find that bug, and he did. Thank you, Tim, and thank you all for watching. Bye bye.